Ladies and gentlemen, welcome back. So we're now going to have a look at the battery itself, and we're going to look at the inverter. So Mr. Bernard, take us through the inverter.
Let's look at the battery first, because this is the question that everybody asks. This is the battery. We are the dealer for this company called GSL Energy. Now this battery is a lithium ion battery. It is the same kind of battery here they use in the electric cars, which we'll show you, or the Tesla and so forth.
Okay.
That small unit you see right there is a 10 kilowatt battery. It is about 22 inches wide and maybe 30 inches long.
Yes.
Yeah. And it is about, I would say, 8 inches off the wall.
Right.
Normally, Miss Davis, if you go to a regular solar site, they have one big room, big like a bathroom or bigger, with batteries, these big lead acid batteries.
Okay.
This battery can be put in anywhere in your house.
Look at
it
this.
is safe.
Right. Safe.
Right. So you can have it in your kitchen, anywhere in the house, and it looks neat and nice. And clean. And clean. And this is a 10 kVA. Right now we have two batteries here. We have one and we have another one down there. This is really for demonstration purposes.
So what does this mean? Menu, enter, up, down?
So this is it has what you call a BMS, a battery management system in there.
Oh, okay.
So you can actually go in there
menu
and change things.
So what kind of changes you can make to the battery?
Well, basically you can see the status of the battery, like how much power is in there, how much it's being charged, information. But you really don't have to touch it or do anything. Yeah, everything is just hands off. Once it's set up, you just leave it. You don't touch anything. There's no maintenance. Over here we have the inverter. Now, to make you understand, I'm going to get technical with it. Basically, what happens with the inverter and the battery? Batteries are DC current, and our utility JPS produces AC current. So this DC current
means what again?
It's like your car battery in your car. Direct current.
Right.
And the other one is called alternating current.
Okay.
So what happens? The solar panels actually produces DC power.
Okay.
And when it produces that DC power goes to the inverter that takes this DC power and converts it to 48 volts and charges the batteries. So these batteries are 48 volt batteries. So it charges the battery, and also it takes some of that power and converts it to AC power to supply your load.
Okay, because in my house I'm using AC power.
That's correct. You are using AC power in your house.
That's why you need this equipment to do the conversion.
Right.
Okay.
So it takes that DC power, turns it into AC power, and it also takes some of that power and stores it in your battery. Right.
Okay.
So everything, all the power from the solar panel comes through this, and you're always going to have clean power going to your equipment. So you don't have to worry about getting burn up computers or burn up equipment, because this is clean power.
Or about smoke and what about gases of gases of
whatever
these equipment, they won't gas or anything?
No, because they are safe.
Okay.
They are in a like for example this panel here, the enclosure is what you call an IP65. Since you're asking a technical question, it really means that it can handle certain amount of moisture, like water can splash, different things. And it is, the way it is built and, so forth. It's built with certain safety features, because these are all approved equipment. This equipment is also approved by the Bureau of Standard in Jamaica.
Okay, so this is bolted down.
It is bolted onto the wall. The inverter is bolted to the wall. Yes.
Okay.
Right.
So once you set it up, I don't need to touch it.
No, you don't need to touch it.
Okay.
Right. You just operate. Because it has error codes, it has different things that will happen if, for example, if you overload it, it will throw an overload and it will give you a code. So when you call me and say, I saw an error code today, I said, well, maybe you overloaded. What's the code? And I can tell you right away.
So overload means what?
If this is 8 kilowatt of power, and if your consumption went to 10 kilowatt, it will trip it out.
Oh, you mean like I decide to give my neighbor power?
Right.
And I decide
or you decide to
run up a big sound system on it or something
right,
like that. Oh,
right,
okay.
right. So you have limitations.
Okay.
Right? You have limitations in how far you can go. With GPS you can do anything, you know, based on GPS has limitations because usually you might have
sometimes you can overload.
Overload.
You do have overload and it trips the system.
You might have a 70 amp system or a 100 amp system, so you can over, and that's why breakers trip.
Right.
It's the same thing. The breakers trip when you have a
so
overload.
with this, with the overload, will the breaker trip?
Well, what if you overload the inverter?
Right.
It trips the inverter.
Okay.
Yeah, it has safety features too.
Okay, so you just your lights go down.
It will just lock off everything if you overload it. Now, one of the things is that just a quick overview. For example, right now I'm producing look like about 0.8, 0.9 power. This power goes up and down. At some points you'll see it, you know, going up. We're having a shadowing situation right there now. This is the battery. The battery is 99% charged and it has 0.4 going to it. My consumption on the building is 0.82 kilowatt. You know, this is early in the morning and this is the grid. So it shows everything. Everything is being shown here.
What these controls?
So these controls are all here so that we can go into the menu and change different things. But you really don't need to do this.
Touch it.
This is really for programming the equipment and so forth.
Okay, so we have actually just turned on the AC unit and we're moving from what was it before?
About I think it was about 0.6 or somewhere there.
So what is it
now?
now?
If you notice, one of the things with the inverter AC unit, it starts to climb. It started at about 0.6 and then little by little the power goes up. It's at now 1.2, 1.3, it will go right up.
Okay.
Now, inverter AC units work like this. What happens, it's inverter AC units are actually DC operated units, really and truly. And what happens is almost, it starts at a low power and it gradually increases. You don't get a spike in power like the old time units.
Okay.
An older unit will just, when you turn it on, it immediately almost drawing 1 or 2 or 3 kilowatt of power.
Right away.
And it runs that high amount of power and then it trips out. What happens with a DC unit or inverter AC unit? It gradually carries the power up.
Okay.
And when the room becomes cold, it gradually ramps down and it comes down and it stays down low. It might consume anywhere like 200 watts.
Okay.
And it will stay at 200 watts during the course of the day. And as you open the doors or close the doors, it will just go up a little 300, 400 watt, and as the room cool down back, it just takes time and comes down back. And that's what happens. If you look here now, we are at, it actually is at 2K right now, and the sun is providing 2.1 K of energy. So the sun is producing all the power and it's not taking any power from the battery right now. The battery is at 100% now, so it's not charging the battery at this time. See, you're gone to 2.6. You're going to 2.7 right there now of power. So that AC now is trying to cool down the room. And within about 5 minutes, when the room has been finished cooling down, the power will just drop and come right down back.
Okay. Is there, so I am into construction, doing a new house, right?
Yes.
Is there any pipes or anything special I can put in now so that I have a seamless connection and don't have pipes all over the place?
Yes, you should consider those things because right now we externally put all the pipes on this old building.
Right.
So this is the junction box and those are the pipes going in the roof.
Right. Okay.
Right. In an installation in a house, you might want to put these pipes in the
wall.
In the wall, right? And with solar, with DC power, you don't use the same electrical pipes. Usually you use metal pipes or you use scheduled 40 pipes, which is like water pipe.
Scheduled 40?
Yeah, use a different pipe. So like these are water pipes actually.
Okay, not electrical pipes.
No, and electrical you use the metal ones. Usually that's what is recommended for DC power.
Okay.
And this is actually a conduit right here. We have all kind of wires inside of this that is coming out of it. So this is one way of doing it.
I see a switch here. What's this for?
This is the DC switch. I can take this and lock off the power going to the battery.
Okay.
For safety reasons.
Okay.
Right. So if we had a fire or we had some short circuit on the battery or something, we can lock off the power on the battery. And this switch here locks off the power of the panels.
Panels, okay. Oh, the panels on the roof?
On the roof, right.
Okay.
The power come here, we can turn it off. And we also have a combiner box near the panels, and it has a switch in there, that a safety breaker switch that we can turn off when we're working on the solar panel. So we have safety gadgets all over the system.
So what is the movement of this energy? So it goes to the panel first, the sun hits the panel.
The sun hits the panel, that's correct.
Then it goes here.
So the sun comes and it comes to the inverter. The panels are connected to the inverter.
Okay.
It is showing here how much power is. This is not necessarily how much power is being produced. This is really how much power, because if you notice, 2.7, 2.6 is how much power that the building is using now.
Okay.
Right, we might be producing more power.
So it hits the panels, it comes to this inverter.
Right.
That does some...
So what you call it is a charge controller. The charge controller convert that DC power. Actually, that power is coming in at 370 volts from the panels.
Okay.
Right, it's high voltage. DC.
So it converts it.
It converts it to 48 volts.
And then it goes
and
to
charges the battery.
And
the inverter now inverts that 48 volts and produce 120, 220 volts, which is what they call split phase.
Oh, so this inverter is doing two things.
That's correct.
Okay, so it is converting the DC power to
48 volts.
To voltage.
48 volts.
48 volts.
Right, but to charge
the batteries. And then it is producing AC power for your consumption in your household.
That's correct.
Gotcha.
Right, that's correct.
Okay, I think
so all your excess.
What does this do?
This is just a junction box with all the wires.
Wires, that come here.
All the wires come here and it distributes it, and
Right.
So forth. Right. That's all that is.
So, ladies and gentlemen, wow! I think Mr. Bernard, you have convinced me to put up one.